Hello, welcome back. In this video session, we will see how to find the influence coefficients for the beams. Okay, for the simply supported beam, to find the influence coefficients, if I is equal to j, for 3 degree of freedom of system, there are 9 number of influence A1, A11 to A33. So, to find influence coefficients of this form, where I is equal to j, that is A11, A22 to A33. Okay, for this form we are using this expression L1 square L2 square divided by 3EIL. What is L1, L2? Let us see by this influence coefficient. To find the A11, the distance of the mass 1 or the position of the mass 1 with respect to left support, that is L1, and the position of the mass 1 with respect to right support, that is L2, and this L, it is the total length. Similarly, to find A22, the position of the mass 2 with respect to left support and the position of the mass 2 with respect to right support, that is L2, and E is the Young's modulus, I is the moment of inertia, and L is the total length. Okay, this expression we are using to find A11, A2 to A33, that is where I is equal to j. If I is not equal to j, for such cases A12, where 1 is not equal to 2, okay, where I is not equal to j, for this we are using these expressions. Okay, bx comma L square minus B square minus X square divided by 6EIL. Okay, but when you are using these equations, when I is not equal to j, okay, in these cases where I is equal to j, 1 1 2 2 3 3, for these cases you use these equations, and when I is not equal to j, then you use this equation. What is B here? B is the, what is the first subscript in I? I is the displacement of the mass I when unit force is applied at the jth position. Okay, for example, if you are looking the displacement at these positions and force is applied at this, then B is B. What is B here? B is the position of the mass j where unit force is applied at the distance between the jth position and the right support, that is B, and we are looking the displacement at ith position. Okay, ith mass, the distance between this ith mass and left support, this is x. For example, if you take A12, then the displacement, the position of the mass 1 with respect to left support, that is x. The position of the mass 2 with respect to right support, that is B. Okay, we'll take this A13. The position of the mass 1 with respect to left support, that is x. The position of the mass 3 with respect to right support, that is B. Okay, and L is the total length, the distance between the two supports. Similarly, A23 is the position of the mass 2 with respect to left support, that is x. The position of the mass 3 with respect to right support, that is B. Okay, what I said you just carefully observe, you will get to know how to find the influence coefficients for the beams problem. Similarly, you find all the influence coefficients using formulas. Okay, similarly for the cantilever beam, to find influence coefficients, you use this equation where I is equal to j, then it is a cube divided by 3EI. Okay, a cube divided by 3EI. What is a? The position of the mass 1 or the position of the mass I with respect to fixed end. Okay, you are using this equation when I is equal to j. Similarly, when I is not equal to j, you are using this equation a square. What is a square? What is a here? The position of the mass I with respect to fixed end. Okay, and this L is the total length. Okay, use these equations to find the influence coefficient for the cantilever beam. Okay, let us see problems on it. Okay, this is the simply supported beam. these two supports, it has 3 masses. Okay, 3 masses means it is a 3 degree of freedom system, so 3 square number of influence coefficients, so 9 number of influence coefficients. Okay, the section it is circular, so I value, to find I value, that is moment of inertia, pi by 64 d raised to 4 are used. Okay, to find a11, a22, a33 where I is equal to j, okay, where I is equal to j, we are using L1 square L2 square divided by 3EIL. Okay, you will see here how a11 is calculated here. L1 square L2 square divided by 3I. What is L1? The position of the mass 1 with respect to left support, that is 200. It is in millimeters, it is converted as meters here, 0.2 square. What is the position of the mass 1 with respect to right support? That is 500, 0.5 meters. Okay, 3E, Young's modulus value. I is moment of inertia, it is calculated here, and L is the total length, that is 0.7 meters. Okay, similarly you find A22, A33 using the same expressions, where L1 is the position of the mass 2 with respect to left support, L2 is the position of the mass 2 with respect to right support. To find A33, L1 is the position of the mass 3 from the left support, L2 is the position of the mass 3 from the right support. Okay, similarly when to find Aij, where I is not equal to j, for this form where I is 1, j is 2. Okay, I is not equal to j, for this form we are using Vx. What is x here? The position of the mass 1 with respect to left support. Okay, that is 200, the position of the mass 1 with respect to left support. What will be the position of the mass 2 where the force is applied, the position of the mass 2 with respect to right support? You substitute these all values. L is total length, that is 0.7 meters. What is B? The position of the mass 2 with respect to right support. Okay, similarly you find other influence. To find A13, it is Aij form where I is not equal to j. What is 1 here? What is x? That is the position of the mass 1 with respect to left support, and B is the position of the mass 3 with respect to right support. Okay, you use the same expressions to find all the influence coefficients where I is not equal to j. Okay, next we'll take one more problem on cantilever beam. Okay, this is a cantilever beam where we have two masses. Okay, now so two masses means it is a 2 degree of freedom system, 2 square number of influence coefficients, so 4 number of influence coefficients. Those are A11, A12, A21, A22. So Aij where I is equal to j, we have two influence coefficients, A11 and A22, and Aij where I is not equal to j, we have two influence coefficients, that is A12 and A21. Okay, to find A11, already we know that A cube divided by 3EI. What is A? The position of the mass 1 with respect to fixed end. Okay, that is 0.2 meters. E is the Young's modulus, I is the moment of inertia. Substitute this value and find the A11. Similarly, we are using the same equation to find A22. A22. What is A again? The position of the mass 2 with respect to fixed end. Okay, the position of the mass 2, that is 0.45 meters, 0.45. Okay, where is A22 calculated here? Okay, it is A22. Okay, A cube means it is L cube here. The position of the mass 2 is it is nothing but L. Okay, so 0.45. Okay, we are using the same expressions to find influence coefficients where I is equal to j. To find influence coefficient where I is not equal to j, we are using these expressions. Okay, for example A12, to find A12, the position of the mass 1 with respect to fixed end, that is A. Okay, this L is the total length. Okay, you calculate A12. Similarly A12 is equal to A21, we already know it, so all the influence coefficients are calculated. Okay, this is how the influence coefficients are calculated for the beams problems, that is for the simply supported and cantilever beams. Okay, in the yesterday video you have seen that for the Dunkerless method, these influence coefficients are used for the beams. Okay, in the next video you will see some more other problems on the influence coefficients. Thank you.